Hey there, team, and welcome to another update on Kilauea. I'm Geology Professor Shawn Willsey. Thanks for joining me. Today is Saturday, January 18th, and we want to discuss what's been going on over the last couple of days. I had a couple days off from doing videos. I was taking my students on visits to some of the other bigger transfer universities here in Idaho, but I'm back in the saddle, been watching this from afar, and I've got some fun videos and images to share with you. So let's go ahead and get right to it. The short of it right now is, as of today, basically a few hours ago, about 10:10 a.m. local time in Hawaii, the eruption has either paused or we're seeing the end of this latest phase, what we've been calling episode 4. Remember, this whole series of eruptions began on December 23rd, on and off. Some have lasted only a day and a half or so. Others, like episode 3, I think lasted about 8 days. But this latest episode, as you can see from the webcam here, appears to be, again, paused or over. And I don't know exactly how the USGS is defining, the pauses and such, but basically we might see a resumption of activity. I suppose that would usher in episode 5 of this eruptive cycle that's been going on there. We had 2 vents here. I'll scroll back here a bit so you can see what this thing looked like several hours ago, but we did have a north and south vent erupting from the southwest side of Halemaumau crater, and those now have gone quiet. There's still a lava flow field out here that's still cooling, and the thermal imagery shows that it's still quite hot, so there's still lava at the surface, but everything seems to be winding down, at least for this eruptive phase. So let me go ahead and pull this back a little bit to the dark hours last night when we had these 2 eruptive vents. You can see those 2 eruptive vents that were chugging along pretty nicely, creating cones. I'll show you those in the daytime, some nice little spatter cones here, and then feeding these lava flows that were coming out from, these cones are up against this western wall of the crater, and so the lava flows were pouring out to the east and filling in at least a good half or third or so of the crater floor. So that's what's been going on the past few days. We've seen some of the lava fountaining from these active vents pushing upwards of 300 feet, 90 meters or so. So they've been very active for the past few days, but now everything's kind of winding down. So let's maybe scroll forward a little bit and see if we can sort of catch, at least kind of sporadically, the kind of phasing out of these 2 vents. So there's the 2 vents still going pretty strong, but the fountains are much more reduced over what we saw over the last few days. Here we are at about 7 a.m. So it's about 3 hours before everything kind of stops. Still plugging along pretty nicely. Eruptions in full swing at this point. Let's scroll forward a little bit. And now you can see here a little bit later that far vent there, I think that's the south vent, if I've got this right, is kind of petering out. This closer vent is still chugging along pretty nicely, but they're both still active. But as we move forward a little bit further, now we're up to about 8:30 local time. And you can see that far vent is, more sporadic in terms of those eruptions of lava. Things have really slowed down. And again, moving forward a little bit further, let's go up to about 9 o'clock. Still chugging along, but greatly reduced overall. And then as we get here towards about, here we are at 9:45, you can see both vents just not nearly what they were earlier. So a great reduction in the gas supply, and of course the lava that's being erupted at the surface. And then by the time we get to about 10:10, this was officially when they sort of called it the death, I suppose, or at least the pause in the eruptive activities. You can see those vents going pretty quiet there in terms of not pushing any more lava out to the surface. Not sure if those vents are still open. Can't really see from this viewpoint. I don't think there's any evidence, or I haven't seen anything yet, that lava drained back down into the vent. We sometimes see that, especially if you can get a system where the lava lake is maybe perched a little bit. You can actually get drained back down into the vent. Don't think that occurred here, but not sure exactly. So that's sort of our view as of today. And here we are with the live view, and you can kind of keep track of this if you want to on your own with the USGS webcam. I'm sure they're going to keep this live webcam operating as long as we still have activity up near the summit area. Moving along, let's look at the most recent update that literally just came out within the last hour as I'm recording this. So this is for Saturday, the 18th of January. About 10:42 a.m. local time, UTC time about 8:42 in the evening. So the eruption within the summit caldera paused around 10:10. Activity greatly decreased about 9:45. North vent and its lava flow stopped erupting, and then the south vent greatly diminished at the same time. The south vents kept going for another 20 minutes, but at a reduced rate. Seismic tremor dropped. The deflationary tilt, so while this thing was erupting, the whole tilt had been dropping, right? The pressure builds, we get inflation. The eruption begins, we get deflation as that magma is moved to the surface. But what they saw here is that as soon as this thing stopped erupting, right around 10, it switched from a deflationary trend to inflation. So more magma is coming back into the system, a good sign that we're probably going to have some sort of episode 5 at some point, maybe hours away, maybe a few days away, and I'll show you that when we get to the tilt meter data. Lava within the crater continues to slowly move, and crustal overturns are expected. So sometimes we get these slabs of lava crust. They get heavy on one end, it's molten underneath, and they can actually sink, flip over sometimes, and then new lava's up at the surface, and then that cools. And so you might see little bright spots on the thermal imagery as this lava lake cools over the next few hours or days. Lava vents, the vents, it says, may continue to glow, and degassing continues at a high level. It's uncertain if lava drainback, as I kind of mentioned, will occur as the vents have built up an internal structure that may stop lava from flowing back into the vent. So basically, they've built up a big enough spatter cone or a construct around the vent that it's harder for the lava to drain back down into the vent, just sort of a topographic change there. So that's our USGS update. Here's just our summit webcam, some of the other webcams. So that's where the fountaining was occurring, and you can see from this image here that was taken just a few minutes ago, basically no incandescent glow. There will probably be some at night because we have this lava field down here on the crater floor that's still glowing. Looking at a little different view here across from the west rim, looking to the east, again at the whole crater floor. Here's our thermal image. So the vents are over here somewhere, maybe a little bit off the image, but you can still see the glow on the thermal imagery of that lava field. So still fresh lava that's slowly starting to cool within the summit crater. And then there's that close-up of the vent, same thing as the webcam there. Map, so a fun little map here. Just to orient you a little bit. So this is kind of where you come in on the main road, enter the national park. Here's the Kilauea Visitor Center for the national park. Volcano House, which is a little restaurant and hotel. There's the Kilauea Military Camp. And then the ring road used to come all the way around here, but remember this thing collapsed in 2018. So the size of the caldera is not just wider, it actually got deeper because the summit collapsed as lava drained out of the summit area and rushed down into the lower east rift zone with that historic eruption that took out homes and added real estate along the coastline. So here's where the active vent is. Lava flow field. This is from the 15th of January, so likely not totally showing the extent and size of the lava flow field. I think it's probably taking up something like this, maybe a little bit less than half, maybe about a third of the entire crater floor, this most recent phase here, this phase 4. And then they have a nice little cross section at the bottom. So if you're not familiar with everything that's gone on here at Kilauea Summit over the last maybe 5 or 6 years, it shows you what our current elevation is right now. So where we're at now is about this elevation shown by the yellow line. But after the 2018 collapse, it was way down here. So this whole pit was a good, what do we got here? Maybe 400 plus meters deeper after the 2018 collapse, and then it filled in with a little bit of water. Groundwater seeped in. Subsequent eruptions have brought the crater floor up, and so we're currently at this elevation here. Here's the pre-2018 profile. So a nice little historic reference there to show you how much this summit region has changed over the last, I guess, 6 or 7 years. Here's what I really am excited to get to here is some of the different videos that they have from the eruption. Let's get those a little bit bigger. And I think the one that'll really maybe knock your socks off, I think it's this one. Is this it? Yes, this is video clip that shows some USGS Geologist. This is on the old ring road that went around the crater in the park, that's since been closed because part of it actually collapsed in and it's unstable, but parts of it are still preserved. So this is probably on the west or southwest side of the crater. But what's happening is the crater's over here, so the eruption's taking place here. This was on the 15th, so this was a few days ago. But the winds, there was winds coming out of the northeast that was carrying these very light pieces of spatter, tiny little clots of lava. The wind was being carried by the wind, and then it was falling down on the ground along the road here. So as I play the video, just kind of look for some of these little pieces of lava and tephra falling on the ground. So there's and then they were actually able to take these as samples. They were actually able to go out and collect some of these small little tephra samples and bring those in for analyses. So there's some of the airborne particles being carried by the winds up and over the crater rim and then falling back down to the ground right along the roadway here. Pretty cool. There's a scientist over there like just picking them up in a bag like pieces of candy being thrown out at a parade or something. Some nice imagery here of those two erupting vents. Again, this is from 3 days ago. But some of the fountaining that was going on. You can see that there's preferentially winds blowing it back up onto that western wall. Let's maybe skip through that one a little bit more. There's some of the lava coming down. So remember, this is dense rock. It's hot. It seems like it's fluid, but this is rock. And so you can actually see it hitting the ground on impact, kind of flattening out. Those sometimes produce things we call different types of volcanic bombs. If there's enough of it hitting down on the ground, enough volume, it's essentially just forming lava that will roll back downhill. Other places here, this is pieces of volcanic lava spatter accumulating and forming that type of material we've talked about before called agglutinate. So a real nice view there, kind of close up of the lava fountaining from the vent and all the accumulation of that material around the vent. So great video there. I want to show you several of these, so we'll kind of jump around a little bit. Here is a really nice one here in terms of, the color is very vibrant, but there's those two eruptive vents on the west side of the crater, kind of zoomed in there. And so some of these fountains, again, got up to be, 90 meters, 300 feet or so at their height. You can see the sort of crude cones that sort of surround these. So they're open on the east side, and that allows the lava to just pour right out. But on the west side, they've built up a little bit of a ridge, a bit of a cone around the vents. Look at the lava field on the crater floor, and then looking back there towards, I guess that's maybe like the north. That's definitely looking to the north there from those cones, or to the east, I suppose, more or less to the east. We'll skip through that one a little bit, see if there's anything we're talking about. Yeah, fantastic videos. If you watch some of these, it does capture sound. A lot of it's wind, but if you I can hear it right now. So if you pull these up, I'll put a link in the video description. You can actually hear what some of these eruptions sound like on your own. A couple more here, just some really nice fountaining videos mainly. And then we've got a helicopter overflight video I want to show you. And then we'll get to some nice images that the USGS took. So this is looking from the west rim, more or less straight down at the vents just below the cliff or the crater rim there. And then looking at it again from more straight on from, I guess, like the south or southeast, looking towards those vents. So two vents. I know when I did my last update, I think one had started before the other, but a second one got going, and then they worked in tandem for some time, and then they essentially died out today around the same time, within a few tens of minutes of each other. One more, and then we'll go to the helicopter overflight. Well, there was a nice little collapse here. Watch this wall here. That thing just collapses in. So that spatter, it's still molten underneath, so it's not very stable. And then it just got too heavy. That's too steep of a slope, and that just collapsed right back down into the vent. So great footage here. Some nice lava therapy for you. If you can just put this on and let it loop, you'll lower your blood pressure. Yeah, just good, clean fun right there. Good stuff. Oh, this is kind of cool here. I forgot this one has this. And let me read the caption to you here so I get this right. So the last clip on this one shows a wind vortex, or what they're calling, and this is a new word to me. I did not know there was a word for this, a lavanado. And that's, from the USGS. So apparently that's a scientific term we're using now. So a wind vortex, have all the heat coming off the lava. You get a little bit of shear, perhaps in the wind direction, and that can create a rotating column of air, similar to a tornado or a vortex. And what you'll see here, it says, as the vortex moves a short distance on the caldera floor, incandescent pieces of crust are torn off and picked up into the air. So the wind speed was strong enough that it actually took pieces of that dense, heavy crustal rock on the lava flow and tore it off and then kind of threw it through the air. So let's see if we can see that here as we watch this. So here's where the crust is kind of coming off. So you'll see these things like flying across the way. Crazy. I can see one way over there. Look at them all getting just torn up. So there's literally a little vortex of air that's ripping up this exposed section of the flow field and then throwing, I mean, some of these are being thrown. There goes a big one right there. Boom. There goes a big one right flying up in the air. There's one over there. Holy cow. So some of these are getting tossed. No sense of scale there, but maybe, 100 meters, a couple hundred feet, perhaps. There's one that went way over there. I've never seen anything like that. That's pretty incredible to have this lavanado, this vortex, just ripping up portions of the crust. I'm going to have to keep this video because that's pretty incredible. There it is coming forward. So you can actually see this as the vortex moves across the caldera floor, is just ripping up different sections of the crust here. Pretty awesome to get those exact circumstances, the vortex, and to have the lava flow field have that crustal layer on top of it, but not be solidified enough so you can actually rip it up. So now it's coming back around. It's over here. Holy smokes, that's like really cool. I'll make sure I put this one in the video description too, because you might want to watch that a few times or maybe show your friends. That's pretty awesome. And then last one here is the overflight from the helicopter. So this is a nice one to give us a little bit of perspective. Again, the collapsed blocks and the immensity of the caldera are on display here. There's the two vents at the southwest edge. So here's our helicopter flight. Again, this is from the 17th, so it's from yesterday, showing us those two vents that are going off. Some of the collapsed blocks here. You can actually see part of the old roadway. I think he'll get a little bit lower there, but you see the center stripe right here, the old road. It collapsed down into the crater as it became, the caldera as it became bigger after the 2018 eruption. There's that road. I actually drove that road in 2007. It's pretty much gone now, at least parts of it. And then I think the helicopter will get a little bit lower here in a second. There's that road right there at the bottom of your screen. So nice view of the vents from above. And then here we are more or less at ground level, I guess looking from the southeast or east, looking towards the vents across the way. And I think this is the one where they're collecting the sample. So this is going to show the USGS scientist shoveling out a big clot of lava from this flow field, putting it in the bucket of water, which quenches the lava instantaneously and allows them to do some analyses. So there's that lava flow moving forward. There's the scientist scooping out a fresh sample of lava into the bucket, let it cool quickly. Go back, get another shovelful. And there you go. Lava sampling in action. Pretty sweet. Brand new rock, born today, or yesterday, I suppose, January 17th. Last little bit of the overflight here, showing this inner crater wall, the fresh lava flow field here. I'm not sure which side we're on. I'll have to see. I don't know which wall we're looking at here. Once we see the vent, we'll get our bearings. I think at some point these shows. But you can see sort of these collapsed blocks. A lot of these, again, from the 2018 event. And then, yeah, it looks like they're going to look back towards the fountaining vent. So I suppose this is the west wall over here, or the southwest wall, south and west wall of the crater. And then there's the two vents erupting and the lava flow field out here in the foreground. There's that road. We saw that at the beginning. Just kind of skipping through that a little bit. Okay, so fantastic stuff there. I want to show you a couple of the images that they collected. There's lots here. I don't think I'm going to show all of them. A lot of them are just, you know, exceptionally aesthetic and scenic. Here's some of that tephra, that wind, that stuff that was being thrown out of the crater, landing on the rim of the caldera. They did have some of the tephra, this wind-blown little tiny light frothy pieces of lava. They had a reversal of the winds on one of the last 2 days. I can't remember which one. So instead of coming out of the northeast and blowing that stuff into a part of the park where no one is, the winds actually reversed a bit. It's called Kona winds. And so they were actually getting some of this tephra landing near the visitor center, on people's cars. And I'll show you some of the Pele's hair and stuff as well. So some nice images here. And let's go to, this is a fun one here. This shows some of the fun samples they were able to collect. So you can see these kind of crazy shapes as the lava gets erupted, gets drawn out or stretched into little strands. You get sometimes these just interesting and exotic shapes in the lava. Some of these looks like little rings or hooks. And then here we have in the middle a high-powered microscopic image of some of the crystals. So this is a crystal of plagioclase, which is a common mineral in basalt. And this is the core. You can see a little bit of a color change right there. And then this is a secondary part of it. So it's the rim or the edge. So there's a different composition, a little bit different color as well to that plagioclase crystal. And that lets us know that that crystal formed, but then had a little bit more added to it. So it represents two pulses of crystallization within the crystal. It's what we call zonation or zoning. And so sometimes looking at those zones or rims or rinds on the crystals allows scientists to deduce, you know, how long this crystal was in the magmatic system. Maybe there was another intrusion that came into it. And so, yeah, so this was like an older crystal that then was coated with some more plagioclase around the edge when the intrusion of magma happened that triggered this eruption here. And then here's an olivine crystal, another common crystal in the basalt, the rocks that we see there in Hawaii. So some fun pictures here. Here's some of the tephra covering the road. So there's the road, and again, just all this brownish stuff is all from these high fountain events, the wind carrying some of that fine material and then depositing it across the road. So because of the location of the vent and the wind, we've seen quite a bit of that. As the lava is erupted, it can pull the lava into very fine strands that actually get carried by the wind, deposited, and this is something called Pele's hair. So these little golden strands are actually, you know, as thin as a coarse piece of hair, but they're actually made out of fine volcanic glass, if you will. And in this case, the wind kind of rolled a bunch of these around like a tumbleweed and made this conical mass of Pele's hair, which is pretty exceptional. Let's see, where did they find this one? This was taken near the visitor center. So it reached this sort of tumbleweed of Pele's hair was up to 22 inches or 56 centimeters long. Pretty impressive. That looks really cool. I've seen clots of it, but not something kind of rolled like that. And then there's some other photos here as well. I won't go through all of those, but I'll put the link up if you want to look at some of the great images that the USGS was able to get. Let's go ahead and round out this update by looking at the monitoring data. Let's start here at the top. Here's the crater floor elevation. So you can see, due to this eruptive, this episode 4 phase that began, I think around the 15th or 16th, you can see a little uptick here in the crater floor elevation. So as we're adding more lava to the surface, that brings the elevation up. So it's come up maybe a few meters or so over what it was before the episode 4 eruption. We might see it dip back down too, because when it's hot, it's more buoyant, it has gases, and then as it degasses and cools, it might sink down just a little bit. So we might see a little bit of a drop in that elevation moving forward. Earthquake-wise, not a whole lot to report over the past week. Very few earthquakes near the summit now that this vent's established and open. Typical scattered quakes along the south flank as it sort of moves towards the sea, and then typical deeper quakes over here in the Pahala region that we often see as well, sort of related to maybe the hotspot movement from depth. Same thing with earthquakes. They ramped up going into episode 4, but once episode 4 began, around the 14th or 15th, those earthquakes have kind of dropped off a little bit, down to about 20 or so per day. Same plot here of earthquakes in their depths. And then this is probably the most important thing on the monitoring data, is looking at the tilt meter. So the blue line is the tilt meter up near the summit crater. So you can see a little bit of an inflationary trend. Then the eruption begins on the 15th, and this thing starts dropping. So it's been deflating while it's erupting. But if you look at the last few data points here, you see that uptick. So the eruption ends this morning at 10:10 local time, and then we get a little bit of an inflationary trend. So presumably we would need to see inflation come back to somewhere in this range to trigger the next eruption. And so that could be a few days out, maybe a week or more. We'll have to see. It depends on the magma supply rate and some other factors as well. The green line is the tilt meter out on the East Rift Zone out by Pu'u'o, and you can see just kind of a slight deflationary trend going on out there, probably just related to the whole events taking place up near the summit. So we'll have to see what happens moving forward. The 5th episode could be a few days away, could be a week or more away. We'll have to see. I'll be out in Hawaii starting on January 29th, so in about a week and a half. So I'm hoping to see and catch some of this action myself. Be very exciting. I'll try to make some videos if I can. Obviously, a lot of this is down in the crater and only visible from some distance, but we'll do what we can while we're out there. So thanks for your support of the channel. Hope you enjoy these updates and learning with me, and we'll see you next time. Take care.